Hi, my name's Bob Greenyer, and I'm a volunteer with Martin Fleischmann Memorial Project. So thank you for joining me this Friday evening. I know you'd rather be doing something a lot more exciting than this, but here I am. And here you are, thank you. And so I have a semi-prepared presentation today. There's a lot I want to share with you, of course, and some of the stuff I've already done, so this should be a little bit easier to go through at least the first part of what I wanted to say. And can everyone hear me? Is that possible? Anyone hearing me? Just let me know. Okay, cheers, thank you. Fantastic. Okay, right, so what are we looking at? I shared this as the title slide for today's presentation, and what I'm going to walk you through is how I generated the image that you see in the background with our two, as far as I'm concerned, at this moment, and I'm subject to review, of course, that is science, these two cores from potentially ball lightning structures. And I walk through how a very similar structure to the one that I've got at the base here of this image was found in a strike of a ball lightning in Hessdalen in Norway, which is a ball lightning type that is produced in the air and is not therefore compatible with the Abrahamson-Dennis model of the production of ball lightning, where it hits the ground by lightning strike, and any similar model that uses that as a basis. And what I've actually done is this is the SEM, and then I'll show you how I achieved the color and the overlay, and then I took the actual color overlay and overlaid that over the top to give it something more than a grayscale. What I did notice is that when I was playing around with the contrast here, it does appear that there is a pole. We discussed this in the last stream, but it really does look like this is a pole. And actually, if you follow a lot of the structures, you know, that are leading up to the pole, there does seem to be some sense that they are coming to that point. So it's either this round bit where I'm moving my mouse now, or it's this actually sort of maybe it's hexagonal, I don't know, but it's certainly round, dark spot like right in the center of the ball there. Anyway, so I thought that was quite satisfying. And how did I come about that? Well, I was asked by David Boutelier during the last stream, could we maybe see this in optical microscopy? And I imagine we can, because now we know what we're looking for. But I thought I'd go back to my Sony Alpha and Laura 5x macro lens photography and have a look at that. But before I do that, I want to say welcome to Brian, Corky, Stewart, FP Angel, John, Gordon, Drav, Dan, the Biomancer Perspective Artifact, and I think maybe, am I getting you all? Am I getting you all? I don't know. RTC, P900, who else have I missed? Odd1X, and Simeon, great to see you. I'm sorry I didn't see your video. Apparently you made a video today, so that's great. Sorry if I missed anyone. Anyway, hi Steen as well. So great to have you all here. Okay, so let's have a look at the first image that I used, and that was this one. And this is for me. It's quite interesting because this was actually the first image that I took with the Sony Alpha when I was developing the technique. And over a period of about 7 months, I went through 3 different cameras and 5 different lenses to come up with the technique and rack focus and so on. But anyway, this was the first image that I felt I was happy with, and it's just funny the way these things work. That actually this was the image that these two balls were on, and I don't know if you can see them, but they're actually down here. This is the one in the center of the channel, and this is one off to the side. And the way I located that is because when I was on the SEM, I took these images, and you can see that in this part of the channel, if I go back, you see it's basically upside down. And in fact, I could have probably rotated either of them, but this is as they were taken, so you'll have to do that in your head. And so the ball that we found initially was this one where I'm pointing my mouse to here, which again is in that halfway through the channel. So I could use that as a registration point, looking at this sort of little sort of bay area, this funny area over here with the kind of like the blue and the green, probably copper carbonate. And I could work that back to find out what possibly may be a feature. And the interesting thing is, and this is quite exciting for me when I get another chance to look at this on the SEM at SciTech again in October, is that I suggested that the end of this channel, that there was a feature in the dead center on the SEM that might be one of these balls. And sure enough, you can see something that looks very similar. It may not be clear to you, but we're going to zoom in, don't worry. But right up here is something that looks nearly identical with the reflection on the same side in the dead center of this structure up here. So for me, this really is pointing to the fact that these cores, as I'm calling them, are the magnetic core of a ball lightning, and that will be very important as we move forward. Okay, so this is the black spot here. No, I've gone wrong frame. That black spot that I'm pointing to now is what I identified yesterday, and that is the shiny spot that I'm pointing to in here. So it's very much lining up that these features that are able to manipulate this matter in such extraordinary ways. And I'll come on to the magnetic fluid side of things with some spectacular imagery probably next week if I can get to it. But it does seem that these are what are at least part of the story for organizing these channels. And so now we're upside down and we're looking at the section over here, which are blown up over here. And this is the first ball that we observed here. And I'm going to zoom in that and change the contrast. And so we have our ball here and our ball here. And I did likewise and rotated the color Sony Alpha 1 image here. So you can see the match between the two here if I switch between these two. Okay? Now, you may notice or you may not notice, but the angle of the SEM imagery and the angle of the photography is not quite exact, and obviously the optics will do a little bit of distortion, so it's not perfect, and obviously the resolution of the optical color image is much lower than the SEM, and so that means that when we overlay one over the other, there will be parallax and registration problems. However, that being said, I thought it was worth giving it a go, and we end up with this, which I think is quite nice. It's a mixture between the, this rather. This is a mixture between the color photography and the SEM. And it really looks like at this scale, you have two iron marbles sitting there in this wonderful terrain. And when you look at this, the fact that it is definitely not anything related in terms of, you know, it's not connected to or part of. I do believe that these were in the center of the channel, because if you remember, this as Henk had arranged it, this channel was made between two brass plates. So I imagine that the metal ball, the core, and it may not have been metal at that point. It might have just been a magnetic core, right? You've got to think of it like maybe it's not actually any elements at all. It's whatever it is, it's a magnetic core, and it may not have any physical presence. And the ball that you would associate as ball lightning, the glow area out to the double there, that is the sort of field of influence around that magnetic core, and that would be this. And if we zoom in, you can see it more clearly here. I've said before that I believe that this inside here, that we've got here, are we still working? The stream died a bit. I don't know. It looks like it's having issues. Okay, we had some connection issues. I don't know whether that just died. Okay. Yeah, I think there's some connection issues. Can you hear me still? Okay. Sorry. Yes. Okay. Good. So you can. I'm not seeing the update on YouTube. Can you see me here? You can hear me. Can you now see the frame that I'm showing you? Okay. Okay. Good. Okay. So you can see the frame. Yes. Okay. So what I'm saying is, the ball here and the other ball down here in the center of the channel, the field is extending out to here, and what you're seeing here is the double layer in my view. So this boundary layer here on the inside, when we looked at the SEM which I previously shared from Alan Goldwater, when I sent him some of what I call these kernels, these kind of like I named them as sort of like sweet corn kernels. I sent him a couple of these, and we found that on the very, very inside, it was high in concentration of carbon. So I believe at the actual coherent inside of the double layer, it synthesizes carbon. And then as you went out, it's copper, and we'll look at other data today. It's copper and then zinc on the outside, the very outside, more so. And I believe that this is arranging this based on its magnetic nature. The carbon on the inside, for whatever reason, I think the copper is paramagnetic unusually, and the zinc is diamagnetic, so it moves away from the intensity of the magnetic field. And these magnetic cells on the surface of the structure, this kind of itonic structure, this mesh-like structure, they have an intensity fall off per cell unit, and that leads to these various cell structures forming on the side wall. Anyway, so what I'm saying is that this ball in the middle here, this iron and oxygen ball in the middle here, is the cause of this area that's fallen off here, and that's the same for the ball down here. I think that maybe this one could have been living over here or whatever and moved around. And we'll talk about this later, because we're going to go on a ball lightning magnetic core hunt with other SEMs. And I predict that we will find in other channels and in other, how should we put this, on other sort of floodplains, we will find these balls, or at least signs of them. And then we can have a bit of fun, because when I go to the SEM in October, hopefully, we can see if we were right. And we already know we've got another one down here, which we can get a wonderful image of. And I'm predicting that this one in the center of this sort of shape is also the same thing. Anyway, so yeah, so that is that black spot there, and that is the black spot we looked at before, which we're referring to here. This is the one that I missed initially under the SEM. Here's the pair together. These are essentially identical sizes. And I wonder if this is something to do with the materials that are feeding it, or maybe it's the duration of the experiment. Can you still see me? Because I can't see. I can't see whether you can see me. And on my what's showing as the live stream, I can only see a still frame. So can someone confirm if they can see? Okay, all right. I'm just going to reset my preview here, because otherwise I don't want to end up talking to myself. I mean, I am recording this, but okay, all right, good. Okay, all right. It's not giving me a preview. It's saying no data. Okay, I can see it now. Okay, good. Okay, so yeah, these balls here, um, uh, maybe the size they are because of gap, the gap between the brass plates. That may have defined the maximum size they could grow to. Or it may be that Henk ran this for something like 100 hours. And so they were building and they were building and they were building, and this is the size they get to. Or it was the gap between the two brass plates on the top that defined the maximum energy that could go into a coherent structure, and then they bled out in between the two brass plates. So there's all kinds of parameters that can be explored to work out whether we can get bigger or smaller ball lightning. But the interesting thing is, and I have to note this, that these two structures, which are very similar in size, they are also very almost identical size to the one that was found in the Hessdalen ball lightning crenellated iron oxygen rich sphere. And so it may be that these things quantize, and so this is one quantization level of the magnetic core, not a quantization level of the overall field of influence of the structure, but a quantization level of the magnetic core. And that may actually be something that influences the size of the ball lightning, because a lot of stream end. Okay, all right, let me see what I can do. You can still see and hear me, but it's saying that the stream has ended. It's fine, is it? Okay. All is working fine, is it? I don't know why it would be showing. Okay, so I don't quite know what it's saying. It's saying, I'm getting it saying the stream's current bit rate of 7,669.95 kilobytes is higher than the recommended. Okay. It's saying that there's an excellent connection. There should be no ads during the stream. Um, okay, I'm going to change the. I don't know, because I'm just seeing it stalled. Okay. Hi, James. I don't know. Okay, so first, can people hear? And separately, can people see me? Don't normally get live ads. Okay, that's not a bad idea. Cool pics. I'll go to my phone and just see if it's still streaming. You can hear and see me. Okay, great. Okay, it's just complaining, or maybe it's just dropping frames and it doesn't want to do that. I will put this on my phone because I know I'll have that on the 4G connection, so it's not using the same Wi-Fi, and so then I know that you can still see what I'm blathering on about. In the meantime, I'll leave you with a much more pleasant image to look at than my mugshot. There we go. I'll leave you with the next slide that we're going to come on to, things to think about. Okay. Well, on the upside, I'm recording this locally, so I can always upload it to wherever later. Okay, so I'm going to have this playing in the background off a different connection. Okay, so I've got my own preview here on my phone. This is a bit funny, so I'm going to put that there. Okay, all right. Then I can have an idea of what you're seeing. Okay, so I'm just going to do one test. I'm going to do a test where I move between two frames. In fact, I'll just play the next frame, but no, I'll talk about what the frame is here. Okay, so firstly, there is a question, you know, are these things micrometeorites? And I've seen several YouTube channels and groups where they go round and they collect detritus out of gutters and in parks and stuff, and they find these structures that look a bit similar like this. I think there's some group in Scandinavia that does it. They're quite keen on it. And they're always calling these things micrometeorites. Now, I have a different opinion about this. And why do I have a different opinion about this? Well, because Ken Shoulders said that basically all lightning starts with a ball lightning. And so he's saying that, like, if you have cloud to ground or ground to cloud or cloud to cloud, a ball lightning forms and then it traces the ionization channel. It works its way between the low potential to the higher potential, wherever that is. Ground to cloud, cloud to ground, cloud to cloud. Okay? That forms the ionized air, and then the discharge goes through this. And this makes sense because you can often see after the first bolt of lightning, there will be a number of discharges through the same channel. And that wouldn't make sense if they were all exactly just straight discharges, and where the discharge itself did all of the ionization, if you know what I mean. And so I've actually shared a long time ago lightning that I took here in Brno at I think 240 frames a second. And you can see just this kind of thing, but other people have used these 100,000 or whatever it is, numbers of frames a second, and you can see the same phenomena of this thing tracing down. And what does that mean? Well, it means that all of these things that people are potentially assuming are micrometeorites are actually the magnetic cause from ball lightning. Now, if you look at some micrometeorites, they actually look like something that's entered into the atmosphere and they've got melt layers and so on. And then you get these things. These things, I think that they're not micrometeorites. I think they are the dead core from a ball lightning. And the reason I say that is because of the placements of the structures inside Vega. I think we've established in these previous slides that they are absolutely in a place that is based on the field structure fall off out to the inner core of their double layer, the inner sheath of their double layer and the outer part of the double layer. Same here, from here to here. And we'll talk about the pomegranate later. And so I think this is very clear. And obviously, there was no meteorite storm going on that happened to land a meteorite in the center of this channel and in the center of this channel at this point, just so that it's in the exact center for the field fall off. It's just you'd have to be stark raving bonkers to think that a meteorite landed here by accident. And I think as we go through the other SEMs, I think we'll probably find a lot of others that are in similar places or, where they might have died and dropped. Okay? So I think the placement of structures in VEGA rules that out. I got some really, really wonderful things to share with you on Sunday, and I hope I can do an even better presentation than this one, improve them through the week. And that would be the placement of structures inside Ultra. But what you already know from Ultra is, firstly, the experiment is very easy to replicate. Two, it forms very specific structures. And these structures have vortices in them. And they have these vortices, obviously, they are focusing energy at a small point. And I believe that that's causing coherence. And then David Butler, when he did his replication, he considered putting a magnet in there. And he found that some of the aluminium peaks or troughs were absolutely picked up by the magnet. And I replicated this basically immediately afterwards and found that in the center there appeared to be a sphere in the center of the one that I picked up, and I shared that. And then I asked Alan, because he had a scanning electron microscope and EDS, I asked him to look to see if he could do the experiment, which he did for about 10 minutes. And then he put the things that he collected with the magnet under the SEM, and in his case he found iron crenellated spheres with oxygen in. More on the sort of magnetite, mahimite sort of ratios than what we found, and that's very important when we come to that. So and I think what I will be able to show on Sunday is the progression through, and also something that particularly is going to blow Simeon Haynes' mind and anyone that's interested in similar things that he is interested in, because what I shared in April the 8th, and then what I found much later and shared, the correlation is literally 1-for-1. It is impossible. It is impossible that whoever did this thing did not know how this technology worked. And now I don't know whether it's an alien, and I don't know whether it's someone who's just trying to help us along in the black world. But what I can say is it is literally impossible that they don't know precisely how this works, and it is very clear to me that they know that it's coherent matter technology. Okay, that is a trailer for what's going to go on Sunday, which I'm really excited about. Okay, so the placement of structures in VEGA and the placement of structures in Ultra absolutely discount the fact that these are anything other than electromagnetic or coherent structures, and they are synthesized, in my view, in those reactors. Now, the next thing is the elemental makeup, and we're going to look at that right now. And for this, I actually have a video. And I actually took this video on the day, and this is one of the frames which is key, and when we play it you'll see. But what you can see here is this is atomic percent down on the bottom right here. Maybe you can't, but I can. Trust me. And the oxygen here is exactly twice the length of the iron bar. Exactly twice the length of the iron bar, which means at atomic levels this is FeO2. FeO2. This is going to be absolutely mind-bendingly important in a short while. Anyway, I'm going to play this video for you. So here is a magnetic iron oxide sphere, crenellated sphere, that was synthesized in an MFMT Ultra experiment by Alan Goldwater in Magic Sound Lab. And in the center of this VEGA Valley channel, we spotted a sphere. It, of course, would be in the center, wouldn't it? And this sphere looks like this. It looks like this. And guess what it is? It is iron and oxygen. Yay! There we go. So that was that. Okay, so to the person that's just asked, how is it an easy experiment to do? Gordon, FeO2 is not rust. It's much more important than rust. Okay, FeOOH is rust. Okay, this is, oh dear, What happened? Oh no! Now I'm seeing a. No, it looks like the stream's ended. No, it says it's live. Oh dear. I don't know whether you can hear me. Oh, this is annoying as. It's okay, Bob. Carry on. Is it? That's just I'm not seeing it. Okay. You can see and hear me. How do you get to see and hear me? I've got an advert now. This is super tedious. No, it's showing something else here. It's showing a different video. Okay, all right. I've got it back in the room. Okay. Oh dear. All right. So yes, FeOH is rust. Okay. And this, what we're showing here is our elemental makeup of what I'm saying is the core. And on spectrum 40, which is actually covered up by this, which is annoying. But anyway, this is just the substrate. There's a small amount of sulfur, and we know that that comes from 2 oxygens fusing, but it's below what you would normally consider detection threshold. Iron, again, is below 1% by weight, which you'd say, well, maybe it's not there. And it might actually be the beam is hitting that, and it's seeing the iron from the iron ball, and so it's actually kind of like a reflected X-ray. So then we got oxygen. That by weight percent is significant. And you would expect the copper and zinc to have some oxides on there, and certainly by the color photography, it certainly looks like there's oxides on there. The nitrogen here is, again, weight percent is very little. In fact, as I'm looking at this, it doesn't look like it's correct, but anyway. Oh yeah, it is because of the amount of atoms involved. Anyway, a little bit of carbon there. Anyway, the important ones are the copper and the zinc, and also this sodium. I have to say, I'm not convinced on the elements here, because they're in an odd order. So we might have to revisit this data. It might be something was copied by the person that copied that. That might be wrong. It might be right. I'm sorry if that's wrong. We'll have to revisit this. But anyway, what is correct, as you saw from the video, is the spectrum 39. Now, if you look at spectrum 39, you can't really see that it includes much other than the iron ball there. But you can see that if you were to project this ball here over to here, it would clip this lighter blob here. And I think that is what accounts for the copper and zinc that you're seeing. This little bit is clipped, and so essentially I don't think there's any copper or zinc in here whatsoever. I think this is almost entirely iron and oxygen, and the manganese is a small amount of manganese, and obviously manganese is also magnetic. And in fact, it might be important that manganese is in there as a dopant to make it even more magnetic, and that might be absolutely key. You might find that this is super magnetic. Now, why do I say that? I'm going to find you something. So what happened was, at the end of the stream on Monday, I thought FeO2. I don't even know if that exists. How is that possible? I know FeOOH, and I know Fe2O3 and Fe3O5 or 4 or whatever it is, but I don't know FeO2. Well, if my machine doesn't break, because I'm going to open up Safari, we're going to look at FeO2. And this, for me, is absolutely earth-shattering. The implications of the fact that this is FeO2 is absolutely earth-shattering. And the reason I say that, the reason I say that is because FeO2 was only discovered and then published on the 8th of June 2016. 8th of June 2016. So this is iron peroxide. And what they're saying is they expect iron peroxide to exist in the deep lower mantle conditions and be key to the Earth's formation. And so this was such an important paper in Nature that another group picked it up in 2017. And they're saying there's an unexpected 3+ valence of iron in FeO2, a geologically important material laying in between oxides and peroxides. But what's amazing about this, which was actually cited in the original paper by the Chinese, recent discovery of a new iron oxide, FeO2, which does not exist at normal conditions, but can be stabilized at very high pressure, 76 gigapascals, and temperature 1800 Kelvin, may dramatically shift our understanding of how Earth is formed and what was a source of oxygen and water in the interior of our planet. Does that make sense? So the other thing about this is that if you want to know what 76 gigapascals is, that is over 750,000 atmospheres. 750,000 atmospheres. Now, Henk could tell me, you know, how much pressure was in his tank, but he was under vacuum. It was pumped down as far as his pump could pump it. There was much less than 1 atmosphere involved. So when I'm saying that when I looked at Lena, and up until I gave my presentation, in fact it was in 2017 that I realized this, but the first time I came out publicly and said it was in ICCF 22 in September in 2019 in Assisi, was that what it looks like is, actually I kind of suggested something in what is Lena fuel, but anyway, the point is I came out and explicitly said it, is that it looks like it's trying to compress things into a small box. Obviously, I didn't mean a box, I meant a sphere. But anyway, because that's the maximum amount of material you can get in the smallest surface area. That is what you get with a sphere. But what this is saying here is that this newly discovered peroxide of iron doesn't normally exist in normal conditions, but can be stabilized at very high pressures of effectively 750,000 atmospheres. That's a lot of pressure. Pressure pushing down on me, pushing down on you. That would be a lot of pressure. That would crush anything. So what we have in this ball is something that really should not exist. This should not exist. This FeO2 here, I'll get rid of the background there because I'm not happy with that at the moment. But this should not exist. This should not exist. And the beauty of the experiment is we have another one over here. So we just need to go to the SEM and confirm that this is also FeO2, and we have a replication. And if we find that the ball up here is also FeO2, we're basically seeing something that shouldn't exist normally on Earth. It may occur in the mantle or lower mantle, but it shouldn't occur on Earth. But I believe it's because it's pushing everything together. It's pushing it. And if you pushed it even harder, it would go beyond iron. And I believe that's what Adamenko achieved. And I believe that's what cavitation can achieve at the extreme. Because you can build and build like a snowball down a mountain. Like what taught Tesla that coherence and resonance can build and build and build until you have an absolutely irresistible force. And it will make other elements. I think it's absolutely astounding. Astounding. Here it is. Here it is. This is not a micrometeorite. Now, when we're looking at the stuff that's produced in the 10-minute ultra experiments, that is more normal standard iron oxide. And given the fact that it's in an environment which is really, 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 really oxygen rich, because it's actually in water, that's not a surprise. But this being FeO2, for me, tells us so much more, and it tells me that this absolutely certainly is not as a result of a meteorite shower inside the tank, inside Henk's lab, in between these two brass plates. Absolutely not a result of that at all. Okay, so essentially, what I've argued is that Ken Shoulders says all lightning has ball lightning. So I think the majority of what people think are meteorites and micrometeorites are in fact the dead cause of ball lightning, which is the precursor to lightning. The placement of structures inside Vega and the placement of structures inside Ultra, and the fact that we've created iron-rich crenellated spheres make it absolutely, for me, certain that this is due to coherence and crushing of matter. I had a presentation that I never published a long time ago called Crushing Matter. But for me, this usurps that. And elemental makeup, the fact that this is, as you see in this next slide here, exactly FeO2, for me, I mean, of course, the Chinese and all the other authors of these papers here could be wrong, and Nature could be wrong in publishing this. So, you know, that is entirely possible. But what they are saying is that until 2016, no one knew that this oxide could exist of iron, and you know, we're on the verge of being able to multiply show that it occurred in multiple places and in predictable electromagnetic arranged places inside a Vega experiment. And so I have to thank Henk really for having the guts to just do experiments, not fancy super expensive experiments, just to have the guts to do them. And I have to thank him for sharing the materials with me. I have to thank SciTech and the people there for allowing me to use their SEM, and you know, and for the people that supported this work, because you know, this is literally, not to coin a phrase or a pun, this is the core of a good part of what LENR is. And remember what I said in the last presentation. In 2009, when George Miley did a survey of 15, you know, well-respected labs working on cold fusion with various different combinations of starting material and various different processes, 11 of 15 reported that the number one thing that they observed was the production of iron. Okay, so I think we probably know why. Okay, the next thing I want to share is something a little bit fun, and it is here. And what you're looking at here is me grabbing a screenshot. And I have said that I believe that the inside, certainly when you look at the double layers here, and you look at these kernels, the inside has carbon on it. And the actual optics that you see in this particular thing shows it to be dark on this, which is, in my view, the area of the double layer here. But this is the inside of the double layer here. and this is just an optical image and me taking a picture of a low resolution optical image on the screen. So we wanted to have a look at this under the SEM, and my prediction was that this would have carbon on the inside edge of the double there, and this is what we saw.
So we're doing a line scan of this part of the VEGA Valley, and it's upside down, as you can see here. And I'm looking across that tongue area, and so you can see here. And on the very inside, you have this high spike of carbon, where it's black.
And there you go. So essentially, that's exactly what we did see on the inside. So I think it's pretty certain now that the inside of the double layer synthesizes carbon. So the point of coherence, and I imagine that this is because when I say it's synthesizing carbon, I believe that the coherent matter layer is effectively just kind of like alpha particles. It's like a skin of alpha particles, and in fact they're not actual particles, it's just one big wave function. They have lost all identity, but when that breaks down, it can't leave alpha particles because they would be a gas, and beryllium decays to 2 alpha particles, so you just end up with it producing carbon. That's the first alpha conjugate nuclei that it can lay down, and that's what it's laying down, in my view. Okay, so so now we're going to talk about the pomegranate, as I call it, and here it is. And the significance of this, I think, is equally as astounding as the core of the ball lightning. And this, again, I believe is an electromagnetic structure, but I believe that this is kind of like it's a monopole made of monopoles, but it may be dipole, and you'll see what I'm trying to say as I walk through what I'm trying to say in a minute. But I believe that this thing at the core here is a very much larger version. Having reviewed the material, I believe that this is a very much larger version of what you are seeing surrounding it. I think that and it's very clear that this is burrowed into the surface, but it's kind of lost the material around the outside. These ones are burrowed into the surface, but they're not so, dug in, and they haven't eaten the material around them quite so much. And so all you're seeing in these ones are this bit at the top, and it's not broken off. And I'll show why I'm saying that, but let me just play this, because this is also a video.
Hi, Bob Greenyer, volunteer with the Martin Flash Memorial Project. So just looking at this part of the western part of the plateau, noticed in the dead centre of this triple point, there was a structure. And if we go into it, it looked like it was a key structure right in the dead centre of these 3 points. And so zooming into it, we came across this feature, which was rather striking, which seemed to hold its own, and that is the structure that was there. And zooming into that, we see it really is rather stunning, and it has a very, very defined boundary. It's kind of mostly hexagon-like in terms of its structure, but it's not a crystal in the way that one would imagine a crystal would be. And it has very, very fine structure on the inside, if you look at this. Very, very fine structure. Okay, so wanted to find out what that was. And first off, did some scales on it, and you can see that over here, this is 13.4 for the outer area, and the diameter is 53.4. So if we take 13.4 and we times that by 4, I think it's around about 53.6 maybe, 54.6 or something. Anyway, it's pretty much a D4D ratio. But there was clearly some difference between the inside and the outside. Now, bearing in mind we're starting with brass, it's not a surprise that we have copper and zinc, but this structure seems to have a higher concentration of sodium in here and also on the surrounding little tufts, and also oxygen, again, on the surrounding little tufts and this particular structure. So this potentially is a North Pole exotic vacuum object, or it's just an exotic vacuum object, and it's capturing the copper and zinc here, and it's chucking material out as sodium and oxygen potentially. But if we go over here to the edges, we will see our triangles. There's a triangle there, there's a triangle there, and down here we're going to have a look at these a little bit closer. There's triangles all over it. And so is it the case that the monopoles make up this overall structure? That's one thing I'd like to find out.
So the elements here that we have, I've taken out the nitrogen and carbon because I think these are the significant ones. And as I said in the video that I took on the day on Monday, firstly, the important facts are, firstly, that the ratio is D4D, as observed by Bostic in the 1950s, doing his plasmoid research. So the outer circumference here is 13.4, times that by 4, and you get 53.6. So, you know, given the fact that it's not absolutely perfect, it's an organic structure. And I say organic because that is what I feel it is. It is an organic structure. And this kind of fits the Evo kind of like structure, and what you're seeing again is this rich in sodium here and rich in oxygen here. So it's like it's ripping the material apart, the copper and potentially the zinc also. But from the data, I kind of suggested that it might be copper. So if we look at spectrum 30 here, this is the area on the outside, but bearing in mind it's much of the same thing. You have sodium at 9.03. Now, where all over this sample, you see a lot more sodium. And you know, where was all of this sodium coming from? It's brass sheets. Why is there so much sodium everywhere? And also, no chlorine. Right? So if this was salt that was contaminating it, why is there no chlorine in here? Okay, and so in this case, you've got all this sodium. There's a little bit of potassium as well here on spectrum 30, and it makes you wonder, you know, is this potentially where the salt came from in the oceans? Okay, if you had something like cavitation or electrical discharges creating the same kind of effect, would this account for the fact that we have so much salt in our bodies and in, you know, the oceans? Could that be the case? And I think we're going to make another argument along that line when we look at the ultra experiment analysis on Sunday. So hold that in mind for Sunday. But here you can see you've got copper 35 and zinc 26. And then in spectrum 27 here, you've got copper 49 and zinc 23. So it looks like it's concentrating the copper on this outer part of the structure. And then on the inside, that drops to 41, which is still higher than here. But you have all of this oxygen coming in. It's concentrated in the center here, and this sodium, which appears to be concentrated also. So if we are to say that this maybe is doing some synthesis of sodium and what do you call it, oxygen, you know, what would be the calculations that we would have to do to see that? And I kind of did that in Excel. It's very rough, and like this is all very raw at the moment. But let me see if I can pull that up without my machine falling over like it did the other day. Okay, all right. Let me see. Okay, so this is a little bit technical, but I've got isotopes here for helium, sodium, carbon, oxygen, and copper. And I've got my the isotope number here, the protons and the neutrons, and this is the percentage in the crust. So 100% of the sodium is 23. And as I've said before, if you, it would appear from looking at Hutchison samples, John Hutchison samples, from looking at a range of different samples, and most recently Savatomova in ICCF 23 found this phenomenon where it would appear that fermionic isotopes get kicked out of, in my view, coherent matter structures because they can't live inside the structure because they can't form a boson condensate. And so I believe that's why you get the sodium being kicked out. And other things like nickel 61 and lead 207, which are the fermionic isotopes of nickel and lead, respectively, on the coral twist aluminium sample from John Hutchison. Okay, so that being said, so I would expect the 23 to be kicked out for that part of the logic about how this type of technology works. In fact, let's just call it nature. So I'm thinking, well, if we're seeing sodium coming out and we know we're getting oxygen and carbon, is it possible that it is a combination of these things? So if you want to produce, and it's actually ripping copper apart. So I didn't do zinc, but I've just done copper here, for instance. And so if you want to get copper 63, which is 29 and 34, as you can see here in the copper isotopes, which is nearly 70% of natural copper, 69%. Then you can dump a helium atom, which we're not going to see, 2 18 oxygens, and 1 23 sodium. If you want it a different way, you can have 2 13 carbons, 1 14 carbon, and 1 23 sodium. And if this is the case, that it's synthesizing 14 carbon, then we can potentially argue that the cosmogenic synthesis of 14 carbon, where you have a proton coming from the cosmos and interacting with 14 nitrogen synthesizing 14 carbon, may not be the whole story, or may not be the story at all. It might be what you can do in a collider using the PN reaction. But anyway, 14 carbon may be being synthesized by exotic vacuum objects in cavitation and lightning all over the Earth, all of the time, in running streams, in water crashing on the shores. And that might be very important for life, because I believe that the 14 carbon interacting with the relic neutrino condensate, sort of coming onto Earth, may be how life is able to germinate, and particularly in the springs, when we have a spring and summer, when we have a higher flux of this condensate because of being closer to the sun, and that being a gravitational body and gravitationally lensing this material. And I believe it's critical for life and for synthesis of elements in, say, seeds, when they require elements which they don't have enough of in order to germinate. So it might be that this is absolutely the tree of life, this technology. And then I've got another one here where it's 3 14 carbons and sodium 23. And you're probably wondering, well, you know, maybe we should test the gas, and maybe we can see some helium, maybe we can see some 18 oxygen, and that would be a good idea. What I do know is that Henk sees carbon, or it looks like carbon, blocking up his window, and the pressure goes up when the reactor is working. So it might be that it's synthesizing gas, oxygen and helium, and that the clouding of the lens port is because it's synthesizing carbon nanoparticles, and they are coming off, and you know. But it might be the case that if you are destroying a metal with this technology, a lot of it would just go to gas and go up into the upper atmosphere, you know. So, you know, there's all kinds of really interesting things going on. Now, the corollary of this is, these are the isotopes of iron. And what I've done here is I've done some equations where I'm basically adding 1 carbon 12, 1 carbon two carbon 12s, one carbon 14, and one oxygen 16, and I get iron 54. If I start with, I don't know if you can see this, you probably can't. Sorry. Maybe I can move it to a different place. I'll move the iron data alongside so you can probably see it better and I can zoom in better. Okay. Okay, so here we go. Let me... So there's another way to... iron 56 is 91.66% of iron. And so if you wanted to synthesize that, we could use 1 carbon 12, 2 carbon 14. So we're using this excess carbon 14 it's making, and 1 oxygen 16. Or alternatively, we could use 2 carbon 13s. Is that right? Yeah, 1 carbon 14 and 1 carbon 16. And then I've got the other isotopes here, which are different combinations that we've got here. And in fact, iron 58, which is not a big concentration, it uses a lot of carbon 14. So it could be that you have this pomegranate that's causing regeneration of lighter nuclei from heavier nuclei. And the micro ball lightning, which is pulling that material towards it, is causing the production of the heavier elements. So you've got one that rips matter apart, and you've got another one that's causing the condensation of matter to denser and denser elements. Could it be that amazing? Could one be a yin and another yang? Could that be it? Could it be it? I don't know. It's just something you need to think about. So back to the pomegranate. I'm sharing this part of slide 83 from O-Day, and I think what you'll see is that I got to the point of realizing that this technology was ancient, and in fact it's eternal, because it is actually nature, and therefore it was always there to be discovered. You just had to bother looking. And you have this Sumerian god here, Assyrian god, Sumerian god, something like that. We won't talk about this twisted loops going all the way around here. That looks very much similar to the twisted loops that we saw going around the ball lightning impact strike that we showed in the last presentation. What I'm going to talk about is the fact that they have pomegranates in their hands. Okay, and we'll go and have a little read about what pomegranate means. And it's all over the Bible and in other religious texts. It's a very, very important fruit. But I said that this looks like a sunken pomegranate. And bearing in mind, I had this image in January 2018 in O-Day. And it was later that I published the one where I used the ancient drum from Vietnam and overlaid a top-down view of a pomegranate, because I believed that it was so important that I wanted to see that on there. And it was only Monday that I saw this structure. Okay, and so I believe that if you look at this structure and you were able to cut the brass in half and see what it looked like inside, I think it's burrowed into the surface. Okay, and what you're seeing here is a pomegranate flower here. And this is a flower where the fruit has started to form. So as it's consuming material through the stalk, it is swelling the body and producing this shape. But actually what happens is ultimately it ends up by having a very big body, and the top relatively becomes much smaller. But I would say that this is probably quite a small structure, even though it's much bigger than all of the surrounding structures. Now, what I did say is I would show you that there are some of the ones around this are also similar in that they kind of lost their top. So I'm just going to go and show that. But what I'm essentially implying here is that if you had something that was consuming material through its base or through its interaction with its environment, it's throwing the material out of the top. And I believe that the pomegranate is shaped like this because electrical nature of nature wants to make something like this that has loads of individual cells that work to cohere matter into something that's of high nutrients, and it produces this part of its structure. I just think, like, when you start to understand how these electrical structures are being made, the self-organization that's going on, it's super complex, but it is life. This was alive. This was alive, and it was doing life. Was it conscious? I don't know. That's the thing. Was this conscious when it was doing its work? And in fact, Ken Shoulders did say that exotic vacuum objects appear to look like they have some sort of consciousness. They certainly interact with each other like they're part of a community. They want to be together. They want to act as a community. Is it another form of life? I'm starting to sound like Ken Shoulders, and you know, I don't think that's a bad thing. But when you see this looks and imitates life. It's imitating life. So let's go and have a look what pomegranate meaning is according to this link which I have here. Oh dear, that's not very good. That link didn't work. Why did that not work? Okay, it's working now. Okay. So the pomegranate symbology, the pomegranate is fertility symbol. The spiritual meaning of the pomegranate with its innumerable seeds is a symbol of the soul. The pomegranate garden is a symbol of heaven. In the mystical traditions, the Canticle of Canticles, Book of Solomon, it said, "Thy plants are an orchard of pomegranates." Author blah blah blah. So this guy, Edward White, speaks of the symbolism of the pomegranate. The pomegranate with its innumerable seeds is a favourite object for symbolism, and in the garden, orchard or paradise has a deep lesson for all mysticism. White goes on to say that pomegranate represents the eternal nature of the soul. Blah, 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 blah. I think this is interesting, this point here. The pomegranate is a symbol of unity, non-duality, and oneness. It's a symbol of regeneration and resurrection. Specifically, the whole quote is, the pomegranate is commonly taken as fertility symbols. But as Farouk al-Arawi informs me, oral communication, in Iraq, pine cones and pomegranates are traditionally symbols of unity. Pine cones and pomegranates, right? Now, where do we see pine cones and pomegranates? Has anyone seen this recently? This. Let me go. I'm going to show you an image here from a previous session in our SEM. Is it this one? Do these look a bit like pine cones? I don't know, maybe. Do they? Do they look a bit like pine cones? I don't know. This is the wall of the Vega Valley. And it reminds me of these temples in the ASEAN Peninsula, you know, like Cambodia, where you have a fractal structure and it's around it. But like, it's kind of like a pine cone, a bit. An individual one looks a lot more like it, actually, when you get one on its own. We'll look at that maybe in a little while. But again, with this The structures are these that we're looking at around the outside. And could it be that the pomegranate is taking stuff out, and you know, it's all part of the oneness, making and breaking, making and breaking. They are traditional symbols of unity. In Christian symbolism, the pomegranate represents multiplicity in unity as the church, with the seeds as its many members, and secondarily, regeneration and resurrection. The position of the cones and pomegranates in the fringe should be taken by palmettes and a universal symbol of regeneration, self-renewal, and victory over death. We see mystical images of the Tree of Life date back to the 4th millennium BC, where it is found in the art motifs of the Mesopotamian cultures. Upon the Tree of Life hang fruit, palmettes, pine cones, or pomegranates. Palmettes, pine cones, or pomegranates on the Tree of Life. On the Tree of Life. Could the Sumerians have known that this is exactly how life works? Let's have a look at the Tree of Life. Let's why not? Why not? Yeah. In fact, before I do that, I'm gonna just show you the other SEM, because I think it's important to see how around that central one you have many other ones which are very, very similar. Okay. So here's the one we've just been looking at. And around that, we found that the tops of these structures here, they also have high sulfur and oxygen. And if we zoom out a little bit more, which one have we got? Maybe we can. No, this one. This one maybe. Okay. You can see its place in its own little universe here. Right? And these ones are kind of like a little bit like cones. I don't know whether they are calling them cones, but remember what Solin said in his patent. You know, these self-organizing solitons of north and south magnetic charge form cones and rods. Are these the cones? They look pretty cone-like to me. Now, if we go over here to this side, you'll see that this one's kind of losing its top. And over here, down here, you can see a cluster of them that are kind of losing their top. It's almost like you've got 1, 2, 3, 4, 5, 6. 6 in a group that then in the center have a bit that's kind of a little bit coming out to be one of these. Yeah? But this is the master of all of these little ones in the environment surrounding it. So pomegranates or cones, pomegranates or cones. Would these cones eventually be the cones that you see on the Vega Valley wall? I think probably they would be. The Vega Valley wall is made from material that's swept around the macro ball lightning. Could this be the pole? Could this be the pole of the ball lightning? Like the North Pole? Sorry, the South Pole. It's the South Pole because it's sucking the material in, but this is the antipole on the outside of the coherent matter. Could that be it? And that these are all substructures that are in the cells surrounding the ball lightning? I don't know, but again, you can see that some of them are cut off. And when they get into groups, and there's a cluster of 6 around here, maybe 1, 2, 3, 4, 5, 6, kind of. And it's eating its way in. This is like a baby version of well, it's like an infant, more like a toddler. This is the daddy-o. These are all the babies, and over here you've got like a toddler on this little bit over here. He's not quite up to it yet, but he can walk, and he's already starting to churn out stuff from the top. I think this is I think it's quite nice, really. And this is for those that missed it in the other presentation. This is what it looks like in the center, and it looks like a frozen lightning storm. These look like lightning bolts, frozen, but within this structure. So, let's have a quick look at Tree of Life. We'll have a look at some Tree of Life images, why don't we? Specifically, Assyrian. And you know what you see in this Assyrian Tree of Life? Is you either see so find one of these, one that's a genuine one. You either see the flower one, which is meant to be like the pomegranate with all the pine cones around. Oh dear, that's not the best. I'm showing someone else's site. Sorry about that. Sorry to the person. So this one, you have a big pomegranate and then all the pomegranates around it, or you have the wherever it is. Oh, there's a version of both of them. It's not the best quality, and you can go and have a look at this in your own time. But you have the flower with all the flowers around it, or the pomegranates, or you have the flower pomegranate or whatever it is, and all of the pine cones around it. And is that essentially what we are seeing here with your pomegranate and your cones all around it? Is this what they are trying to say in the Tree of Life? Are they saying that is what this is? It's the regeneration, where it's taking copper and potentially zinc, and it's synthesizing oxygen and carbon, which are pretty useful for life. Oxygen, carbon, and salt, sodium, from this particular element. From different elements, it might make different elements, and that is certainly the experience that we've had. Okay, so I'm going to take a break and ask if there's any questions now. Maybe people can say, maybe they've got an opinion on things that they would like to share, or some ideas. But yes, you can see the pomegranate, and then you can see the cones around it, and you can see like a little pomegranate getting formed over here. And there we go. Yeah, everyone asks about making gold. We've already made gold, and we've already made silver, and we've already made palladium, in various experiments. But it's small quantities. Really, what you want to do is go to a bit of dead space, spin up a big Evo, make it blow up, and come along 4 billion years later and get someone to mine it for you. That's what I would do. I think what excites me is that I believe, and I hope I will demonstrate, that this will be a technology will allow us to get to other planets and other galaxies well within lifetimes. Other solar systems rather, well within a human lifetime, and with its potential to instantaneously freeze things, we would be able to spread across the cosmos. And when we get there, if the planet is at least in a habitable zone but isn't habitable, we can use this technology. And the Tree of Life, which I believe we are seeing here, which the Sumerians and probably the G culture, and in fact all across the world, I think they knew this absolutely. They completely understood how nature worked, and the iconography is, I mean, either they're channeling the Akashic record, and that is how they came up that symbology, and they just happened to choose things that look like pine cones and things that look like a pomegranate, and revered those structures, and it gave them the properties which the structures are actually doing in the Vega Valley, out of just sheer guesswork, or they actually knew what they were talking about, and I think they probably knew what they were talking about. Bob, did you notice there was almost a spiral of cones beside that Daddy-O cone? Yes, I'm pretty sure that if you did a statistical sort of analysis on this, you would find expected patterns, let's put it like that. I'm going to show you actually in another part of the Vega Valley where the structures are absolutely pointing to the magnetic field of the magnetic fluid, the electron condensate, which is around the center, is the double layer skin of the ball lightning. Looks like some of the baby ones slightly spiral into. It would not. Yeah, I guess what you're saying is here, like this group here is kind of spiraling into here, maybe. Yeah, I mean, yeah, probably it is the case. Certainly, this is kind of pointing into there. Maybe this group is pointing into there. This point is pointing into there. This looks like it's going around in this vortex. So if we go into a much closer shot, and I talked about this the other day. If you look at the right side of this, and we've actually got this in ridiculous res, you can see that the angles here would suggest to me that there's a vortex going around to the left on this scale here. You can see that it's going off at an angle. So if we pull out, I would suggest that the vortex is going around anti-clockwise on this, and so it would stand to reason that the structures here are going anti-clockwise and coming into it, anti-clockwise coming into it, anti-clockwise coming into it. So yeah, well spotted. You know, I think probably since the beginning of 2017, I've said, look, we're not discovering anything new, and this can't possibly be owned. It is nature, and there's nothing beyond this. This is all there is. It is the God's toolbox, and I say God in gods in inverted commas, because using a little one or other aspect of this technology, you can do things that would make you appear as a god. But you're not. You're just using nature, how it actually works, working with nature. I think probably for much of the last 1,000 years or more, we have been working against nature. We've been. It does like to make and break, and you don't want to get caught in the crossfire, because this can destroy anything. Like this pomegranate here. You know, if this pomegranate is eating through a building, you know, or you're mining with it, it will convert whatever it is into gases. So let's say we wanted to tunnel with this, well, it would make a very, very effective tunneling device. You would have to keep it charged, and that's a bit of a challenge. But you could make, you know, on a boring device, rather than having a diamond tip or a tungsten carbide tip, you would have an electromagnetically charged ball lightning, and that would form your cutting head, your cutting tooth rather, and it's coherent matter, and does not matter what you are going to cut, it will cut it, and it'll convert it, let's say, to gases, and then you just pump it out and you make a lovely, beautifully hermetically sealed tunnel that you're boring through. And so, you know, if you had access to this technology, or you knew you were going to get access to it, you would develop a company that would do mining and boring tunnels, wouldn't you? You know, if you had the access to this technology and you know that it can negate the weight of gravity and do propulsion, then you would develop a company that could do, I don't know, lift things up into the sky. And if you know that it can convert protons into light and leptons, or it can cohere matter that's not normally considered energy into electrical energy potential, then you would probably have a company that did electrical transportation. So, you know, and you would pretend that you had invented it after a period of time. Enough said. To the right of that cut-off cone, are we talking about this one here? Or this one here? I don't know. Anyway, I like I say, I think we'll be spending a lot more time with the Vega Valley. Okay, I'm going to answer some of your questions, and then I'm going to go and show you some other things on the Vega Valley, and then we're going to go on a ball lightning core hunt, because I want to kind of identify where these various structures are, so that I know where I'm looking in the next time I'm in the SEM. If people didn't know what I was talking about when I was referring to the twistiness that's going around the outside of the Assyrian pomegranate holding god, I was referring to this twistiness where you have a loop that goes round and 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 a loop that goes round, and it sends you around the loop, doesn't it? Okay, and I've got this at a ridiculous res here. You can see what I'm referring to is this part down here. You can see it in the ridiculous res. Okay. Oh, it's interesting. People are talking about Elon. I wonder why they would do that. There's such a thing as a figurehead, David. If you don't want people to know you've got something, you probably want to allow people to play with, you know, old technology and make out that that's modern. And by the way, this is older technology. It's eternal technology. Have you done the calculation on the aggregate that focuses and feeds these fields with various gases and materials in order to manufacture relevant quantities of specific elements? No, Elias, no, we haven't. As I said to Aarhus University a good number of years ago now, there will be entire universities that have many departments, each of them who are dedicated to looking at aspects of what this technology can do. We are looking at trillions of man hours of research, rediscovering who we are, how we came to be, how probably we came to be on planet Earth, how the universe ended up the way it is, how it is able to be manipulated by this technology from the macro all the way down to the microcosm, and you know, all of the above, really. So my role, as far as I understand it, is just to work with those that are willing to work in an open way, and try and get to a point where people can see it for what it is. Bob, are you hypothesizing that he is set up to make transitions into that, or that he's already doing so but privately? I would expect that at some point the company that is the family of companies will release these kind of technologies, and it will appear as if they were a natural discovery because this company was working in those fields. And I've said that for some time, and I do not think it is any coincidence that the company was called Tesla. I do not think at all. But I do believe that Tesla himself was looking at ancient texts and understanding, and himself was taking inspiration from the Arabic and Middle Eastern and so forth. I think that this has been a pursuit of the West to understand this technology that clearly was massively used all over the Middle East and in Afghanistan and through into North India. But even before that, I think they were probably the last people to have it. I think even before that, it was used all over the world. And if you look at the fact that the auspicious symbol is nearly in every culture, and other symbols which I will walk through, I will step through them and why they are relevant. They are in every culture. In fact, every major symbol that you know of, that people, if you go to a crystal shop and you look at the symbols on the wall, pretty much all of them are walking through aspects of this technology. Which is just nature, by the way. I call it technology, but it's just how it works. I've explained this before. It's like he may not know that he is going to be developing these things, but he may have been said, like, if you do the X, Y, and Z, then at some point in the future this will happen, and or it might be that someone will be given a little bit of an insight who's capable of filling in the gaps and will discover this a particular aspect of what the technology can do. They'll give it a different name because they don't want people to, whoever they are, they don't want you to know everything about how it works. They just don't, because, well, you can see why. As I've said many times before, I don't really blame them for wanting to hide it. But the point is, we as a species, our ancestors used this technology all over the world and probably all over the cosmos. And we are, this is not just our birthright. I believe it defines our species. You know. So Bob, did you find more spheres on there or not? Well, we'll have a look. Let's have a look. Let's see if we can find some more spheres. Let's go on a sphere hunt. Let's go on a sphere hunt. Okay. Before I do that, I'll just show you what I said I would show you, which is a image from another area on the Vega Valley, and I'll come back to this in a separate presentation because it's too significant to just. It's part of a series of images from 24th of August, but I haven't been able to find the time to go through it because there's bigger things to show. Right, so here it is. And this actually is looking into the main channel. So this is very close to where the gap is between the two brass plates. And what you can see is there is a side channel over here, and these cones, these kernels, they all point to the side channel. Okay, and you can see how beautiful they are in terms of their same, you know, similar structure. Okay, I'll get rid of my mugshot so it's not in the way of the imagery. Okay. I'm going to zoom in more because I can see on the live stream it's actually not capturing all the quality that I can see. Maybe I'll upload this stream separately. So you can see here these cones and the cone. So this is a big cone, but on the big cone there is a cone, and on that cone there's cones. So you can see how self-similar it is. But they point into a side channel here, where you would have another plasmoid, another ball lightning. But in this one, you can actually see that this is in the main channel, and in the main channel, they're all kind of like pointing directly up. And you can see that as you go from over here, they're pointing to the right, and as you come here, there's almost like it snaps. It gets to here, and they start pointing into the main channel. And as it goes closer to pointing to a ball lightning that's directly, perpendicular to it, they kind of like point straight forward. And these are pointing straight up, and if we go to the other side of the channel, if you could, then you would see that they are pointing into the channel in the other direction. Okay, so actually, I'm going to show you a couple more slides from this because what you're looking at here is very special. This is directly below the ball lightning in the main channel that you saw on the video that I shared many moons ago. And this is super fluffy. And when you actually look at this on the optical image, this is like jet black. But all over the optical image, let me go and get the optical image because I'm going to do this now. Why not? Before we go and have our ball hunt, let me go and find the optical image that I need to show you here. Now this might break my machine, but anyway, we'll see. No, I didn't want to do that. So you can go and see this in YouTube in 4K. This is only going to be 1080p. But we've got the area down the bottom right here, which is our polarized area, red and green polarized area. I will come back and do a separate presentation on that. In fact, the significance of this is huge. And Dan Moretti's question when I was talking about that will be answered in the last segment. And you can see the cones pointing into the structure here. I imagine that along this line we will find some ball lightning when we come to look at it. But what confused me, this is the main channel over here on the left. And this is what I'm referring to when we're looking at what we're looking at under the SEM. But what I couldn't understand was that in a regular fashion, there were these sparkly bits, these white bits all over. And I thought, well, it's kind of dusty, but it's not dusty. And why are these so white and everything's so black? How is this occurring? And it looks like it's sparkling and reflecting the light. You can't really see it under this imagery. So I wanted to know what was causing these white spots. And I'll actually zoom into the image. Hopefully we can do that. Is it going to let me do that? Because the image is much higher resolution. So what I'm referring to are these white spots all over here. What are these white spots? I couldn't work out what these white spots were. I thought, are they dust? No, they don't look like dust. Was the problem with my lens? You've actually got a bloom around them, you see? So you've got this one here, and it's got a bloom around it. And this means it's kind of like kind of refracting and also dispersing the light. And so this was much more interesting to me than just a bit of dust. I had a bright light on it to capture it, and that really has frozen my machine. Oh dear. Fortunately, the streaming machine is a different machine. Right, it's going to catch up. There we go, it's catch up. It's not died on me. Okay. So we now have an explanation, or you will have an explanation. And I don't know whether I have the EDS data for this, so you'll just have to take my word for it. Sorry about that. So we are now looking at this. This is a similar part of that channel. So this is a side channel, but this is coming into the main channel. And I showed you this, which showed that it's a bit fluffy. It's a bit fluffy. But I thought, God, let's have a closer look at that. Oh my God, this is super, super fluffy. Look how fluffy this is. Look at the scale here. This is 20 microns. So this is 2 microns. So a distance kind of like there to there is 2 microns, which means this is nano fluffiness. This is seriously nano fluffiness. And one wonders how, with a ball lightning right above it, how this can be so nano and fluffy. And I go even closer in than that. So what we're looking at here now, this is 5 microns. So this is 0.5 of a micron. So 0.5 of a micron there. So that is 500 nanometers. So this is very, very fine. It's coming down to a point which cannot be resolved by the microscope. This is super, super fluffy. So there's 2 points about this. One, when you look at it under the microscope, it's carbon rich and it is essentially copper oxide. And why is that important? Well, I gave a hint in the My Movie presentation. That I think it was My Movie. Anyway, the point is that copper oxide is a very good photoelectron emitter. So if you have condensing matter and a ball lightning forming, and it's emitting high energy photons or X-rays, and it's going into this, maybe that is releasing more electrons. So it's kind of like a self-feeding process. And so it's self-supporting. So it's grown a structure that kind of is able to feed itself. Anyway, so that is quite nice. But what I noticed actually in this was that there were some things on the top here. And over here as well. And they seem to be coming out of the tops of these structures. Now we know these structures are effectively these kind of cone-shaped structures. If we go back to this one, they're kind of much of the same thing. Oh no, my machine's freezing now. Okay, so you can see that it is the same structure. So you have a cone here, and as we come across the image, it comes forward. But as it comes more to where you've got the most intense ball lightning, you have these cones becoming this fluffiness that I showed. And on the top, look what you see. You see this beautiful thing coming out. And you don't, because you're not looking at it. Sorry. Sorry. What I'm saying is that these fluffy structures, they're the same thing that's over here. So the kernels, which are kind of like harder edged over here, when they come to the most intense ball lightning, where most of the ball lightning is born in this structure, yeah, you're going to see it, where most of the ball lightning is in this structure, they become fluffy. Sorry, you can't see the fluff at all. So I was referring to this fluff. I'm very, very sorry. I'm referring to this fluff. Oh dear. You can tell it's live. I'm referring to this fluff, and I'm saying that this is 20 microns, and this is 2 microns, and so this is very, very, very small structures. And here, this is 5 microns, so the scale down the bottom here is 5 microns, so this is 500 nanometers. So 500 nanometers is that big. So this is 100 nanometers at its base, maybe, and then down to very, very, very little. Okay, and that I'm saying that this is formed at the point of most energy intense structures. So if you recall, there is your 2 brass plates and the brass underneath, and the ball, like the anode is above, and in between there you're forming the ball lightning. And that's where the electron condensates are being synthesized. And when I was looking at this image, I noticed that there were these things on the top of some of these under the main channel, under where the ball lightning would form. And we know that the inside of the coherent matter sheath, the inside of the ball lightning double layer, is where we're getting carbon. And out of the top of these, you're getting these structures. Now, I can tell you, basically, in my view, they are diamond. And these were observed by Matsumoto, these little sheets. And they appear to be coming out of the tops of these things. And in fact, there's kind of like ones that aren't quite resolved. But let me find that nice one. I think it's up here. Where is it? This one. You can actually see it's like coming out. And I think up to the left of that, there's another one here. Here. And then up to the left of that, you've got two. So you've got one coming out of this one and one coming out of this one. So there's two little tips coming out, and it's spewing forth this diamond. Here you got almost like a heart-shaped section with the carbon coming out, and it's almost got a trail that goes off to the side. In fact, I zoom into one of these, and this is the one that I took the SEM for, and you can see that this is 20 microns here. So this is 2 microns. So this here is about half to maybe 2. It's about 1 micron thick. This 1 micron thick here. Okay, and this is essentially carbon diamond. And so I would imagine that these are formed in the inner side of the coherent layer inside of the double layer. And that is that. So yeah, I think no, this isn't fluffy carbon here. This isn't fluffy carbon. This is, and when you go and have a look at the image, so if I go back to the image maybe, you can see what I was referring to here. Not on that one, in this one. So it's in this central channel here. Yeah. In this central channel. So these little cells that you see here, these cells that you're seeing, they are that red dot is a problem on the camera sensor. These little cells here, these are the fluffy carbon. So they just look like black thing, but I think they're black because the light goes in and it never returns. And the little sparkly bits, the bits that have these blooms around them, this is a classic thing in optics. You've got a bloom here. This bloom is, I think, the light's going in and it's refracting through the crystals, or the crystal of the diamond, and it's spreading the light out over the top of the copper oxide. Okay. Diamonds on the soles of her shoes. Yes. Corky. I think in the coherent matter, in the inner sheath where it's coherent, and I think you'll find that the binding energy at that point is so intense that all matter is consumed or denatured. And this is how you would make a force shield. You create this thing around the object you want to protect, and the coherent matter, like something comes in, it just, as fast as it comes in, whether it's a laser, other EVOs, a projectile, a nuclear projectile, doesn't matter. You just come in and just go, it'll be consumed instantaneously. Like if a nuclear weapon goes and hits like this kind of coherent matter material, as the weapon goes in, it won't feel, how should we put this? It won't feel back pressure. It'll just be consumed like it's slicing, it's doing a Boolean action. It'll go through the nose cone. It'll go through the parts of the trigger device. It'll go past the only way it doesn't really matter if you detonated it just before. It doesn't matter. This is how you make trick shields from Star Trek. This is how you do it. Yeah. Anyway. Okay, so let's go on a hunt. Let's go on a hunt. So where are we going? I'm going to find the directory here, and we are going to look at the SEMs and find see if we can find any other ball lightning cores. So I took a bunch of images at this resolution, and so these are 64 megapixel images. They are when they update. Oh, no, that one isn't. That one isn't. That's a low resolution one I use for the presentation. Right, I'll go to that image, but the real image, which is this one. Okay, so this is the original image, and so we identified that this was our first ball lightning, and this is as big as we're going to see them. And there's another one over here that's not so highlighted in this particular SEM. And so what we need to know is, can we look around, and there's potentially one here, and we can look at maybe the structure of what's going on with the valley itself. So I think there's definitely one here. This one may have come from another event, and I believe we're seeing one in here, and I'm looking forward to going to look at this under the SEM to see if this really is a ball lightning. I'm going to close my web browser because that's going to be eating resources, so give me a second, and then hopefully we won't quit Safari. Okay. Okay. So we're looking for something similar to what we had up here, and I think that this is a smaller one. It's at the end of a channel, but it may be the same. It might be slightly buried in the surface. Don't know. And it's still struggling. I'm going to kill Photoshop. Maybe that will improve matters. Now over here, do we have anything that could be a candidate? I don't see. Maybe this one. Maybe it's in the wrong place. I don't think that's one. So, like I say, we might find something. We might not. Oh, what's that? Is that something? No. No, that might be there. Don't know. Is that one? Don't know. Not convinced. Not convinced. No, not convinced of that one. Right. Oh, hello. That might be one. That might be one. No, I don't think so. I really don't want to be wasting my time. It's an expensive machine to use. Right, let's go and have a look at another area. Let's go and have a look at this. Okay. Now, I would expect to see one in this one. Oh, hold on. What's that? What's that there? What's that? Well, maybe. Look at this. This is kind of like, yeah, no, that, I don't know. Maybe this is the center. I don't think it is. No, I don't think so. No, I'm not convinced that. Well, there's some sort of trail coming in here. Maybe there's one hiding under there. Maybe there's one in the bottom of this, but we can't see it. There's just too much that's fallen into it. Not convinced of that. Oh, hold on. What's that? No, it's just no. They're very, very specific. So not getting a lot of love from this part of the area. No. Interesting. This is actually the inside of a channel. This is quite an interesting structure here. Look at that. This is the inside of the channel, and this is kind of the outside, and got some kind of cones going on there. No, I'm not feeling it with this one. Let's go and have a look at another shot. What do we got here? Of course, we may find nothing. That looks interesting. I might... No, not convinced on that one. No. Look at the cones here. Quite lovely, aren't they? They look like molars, don't they? Like teeth. Oh, there's a splat over there, which is slightly out of focus. Now, I wouldn't mind having a look at that. That looks interesting. That looks interesting. Okay, so on VVO2, bottom right, I can look at the video later, and I think we've got something here. It's like struck the top of that. So I think that one over there looks interesting to me. Most interesting thing I've seen so far. Oh, what's that? What's that? What's that? No, that just looks like a hole. So I'm not going mad. This is what I do in my free time. I spend a lot of time with SEMs, seeing if there's anything useful. I mean, of course, you can see this twisting blobbiness as it's going across the surface. We're going to see some more of those. Don't worry. How it sloshes it around, as Ken Shoulders said. Anything in this one? This one, maybe we see something useful here. That might be interesting. This one here, I don't know. Not feeling it. Not feeling it. If anyone's getting sick, let me know. Okay. Over here. Oh, hold on, what's that? Maybe. Don't know. This one looks encouraging. Don't know. I'm not feeling it. I'm not feeling it. What's that? What's that? Oh, this. I like the look of this one. I like the look of this one. It's all on its own. It's black around it. So that's on VVO3. Not so convinced about that. Because remember, we're looking for something at about 27 microns. So this is 2 millimeters. So that's going to require too much of my brain power right now. So the twisted vortice area that we showed before is this one. So you can see this is much further out. And actually, it looks like even there might be something useful there. That might be useful because we have... Oh, damn it. It's just off shot. Oh, dear. Oh, no. No, you see, right. So this is how we can be fooled. That one looked potential, but I don't think it is. You see? So it isn't. Okay. All right. You getting bored yet? That could be something. Don't know. Looks like it's sitting in there. Ah. Is that in the middle of the channel? There. There. That's a potential one. That's a potential one. You see how boring my life is sometimes. You're having to live it with me now. I hope you've all got a beer or something. Okay, I'm liking this one. I think this on VV09. I think we might have some success looking at this one. Okay, it's just slowing down a little. All right, I'm not getting a whole lot of love from that one, so let's have a look. Did we look at that one? I think we looked at that one, did we? This is a little bit further out. No. Maybe. Now this may be one, but it's kind of like messed up its environment. It's gonna like splat. So I actually would like to have a look at that one. Is it a piece of detritus that's just fallen there? Maybe, but it's in the center of a channel. I don't know. It's not in the center of a major area. So I don't know. I'm still not feeling that one. What's that one? And this is interesting. We got one here that's in the center of a channel, and it's also got this kind of stream coming. Okay, I say that one I want to look at. That one I want to look at. I think so. Let's mark this down. This is VV10, and it's in the kind of topish right corner, center of a channel. There are some other interesting ones. Maybe this one here. This one may be buried. But this one, to me, I think we might be seeing another core here. And, you know, this is what you've got to work with before you can actually zoom in. You know, you're going to have to work out. Now my machine's frozen again. It really doesn't like being that zoomed in. Maybe I can avoid that by not being that zoomed in. Yeah, so it's this one here. I think we've got a good chance, and it's interesting because I'd like to see what it's done with this trail over here. Yeah. Right, so we got another one maybe in the center. No, I don't think so. Oh, this one looks good, even though it's off to one side. Okay, so I'm liking this area. Anything out on the Badlands? Anything. Ah, look at these splats. Look at those. You know, something's come out. Another heart shape here. This is kind of like the other one with the same spirally outside, almost the same structure. I call these pretzels. You see them everywhere. And it's just not as well resolved as the other ones. Maybe if we zoomed in with higher resolution, you would see it being as resolved. You see how whatever happened here, it just came down and changed it. Maybe. No. Right, well, we already know that we saw our... This is where our pomegranate is, in here. This is the pomegranate. Are we seeing now? Oh, okay. Hold on. No, not that. Is that something? No. Here's a kernel that's just fallen and broken off and fallen into the main channel. Now, now you see that this is a kernel that's fallen off and broken into the main channel, maybe off this side wall here. But it is in the center of this area here, which is quite a large radius. And one wonders whether it's actually on top of one of these magnetic structures. It'd be interesting to be able to get some micro tweezers in there and lift it off and find out what it's buried. Look at the wall here, the wall of the channel. Well, it's harder than you think. So you know, it takes quite a long time to capture one of these 64 megapixel images. Now that looks interesting. I want to have a look at that. So that is on VV11. If someone would like to just timestamp in the video later where I should be looking, that would be useful. Look at this bowl here. It's like the ball lightning maybe came across here, did this damage, and then maybe went on somewhere else. Okay. Not getting a lot of joy from that one. Okay. What are we seeing here now? This is quite a bit more messed up, this area. Look at these structures here. Look at them. Maybe this one. Are you bored yet? Oh, God. Difficult to see anything in this. It's quite a structure by itself. So again, maybe something in the center here, but it's buried itself. This might be interesting. That looks interesting to me. I want to have a look at this. This looks shiny and round, and it's in the top of it. It's like, looks like it's burrowing itself in there. This looks interesting to me, this one here. So this is on VV12. That looks big, actually. How big is that? What are we on here? This is 2 millimeters, so that's 0.2 of a millimeter, 200 microns. So 50, actually that looks about the same size. So 50 would be there, and 27 would be there. Yeah, that's about the same size as our other ball lightnings. In an interesting place. I'm not entirely sure why it would be there. Oh, and there's another one up here. What's this? That looks nice. I like the idea of this one. That looks interesting. So, but this one I definitely want to have a look at. I know it's in a crevice, but this looks like a lot of the ones that I saw in the Imperial War Museum. Yeah, okay. Maybe this one here as well. This looks like one as well. This is in this kind of the center of channel, maybe. I don't know. Yeah. So I think on this one, this area, this whole area on VV12, one here, this really big one. This looks like it's a maybe the next quanta up. Be really interesting to see what that is. And then the one here, this one's quite nice. Yeah, so I think we got 4 or 5. What do we got? Ooh, hello. Hello. No. Oh, that might be into. Oh, hold on, we got some balls here. No, not convinced. Not convinced. In the center of this channel, what's that? Don't know. You can actually scroll around on the SEM and look at areas, but it's actually quite time consuming because you're actually physically moving the sample. Now this looks interesting. This looks interesting. I might want to have a look at this area here. Something's going on here. See more gloopiness here. The way it interacts with the base metal. Oh, hold on, what's that? No, I think that's just a ball of gloopy metal. See how it gets out of focus on the edge? Even SEMs have a problem with that. Now that's interesting. Oh, now that would be really good. I think we might have here, this one here, can you see it? This might, I think that is, wow, fantastic. So what we have is, this is a main channel and something has come out of here at some point and it looks like it's done some damage, it's done some damage, it's done some damage, it's done some damage, and it's ended up. This, okay, I'm really, really excited about this. I think we have a core here, and I think that this is material that has been manipulated as a small ball lightning came down here and came to rest over here. This is the most exciting thing I've seen this evening. Because I've seen the other stuff before, but this for me, right, I want to have a look at this. I want to have a look at this. Now, it could turn out to be nothing and a dead end, but this would show, if it is the case, that these damage marks might well be attributable to this feature having come out here, and that the ball lightning is what's traveling across, and that the core is there because it died. So I'm excited about that, and that is VV13. VV13. You know, if I'd have thought about this, I should have come up with a better way to to make this interactive other than you just watching me scroll around something. Okay. This looks nice as well, this ball here. This ball here. I'm liking that. Okay, this sample VV13, I think this has got potentially a very significant structure on it. Again, in the kind of center of here, of this end piece here, we're seeing something that, you know, at this distance, it might be a pomegranate in there, but a young one. But for me, I think potentially the big win on this is this one here, where it's burrowing through the material and ends up with a ball there. Okay, and any more for any more. I don't know whether that's all I did. Maybe that's all I did. You'd probably be happy. It's like, make it end now, please. Stop. Okay, so we got some work ahead of us to have a look at that lot. So just so you know, this is a composite shot that I put together with the misregistered, oh dear, I say that, but it's like a 500 megabyte TIFF file, so maybe I'll, oh no, there we go. So I think this is 500 micron scale here, so it's about 500 micron from this point where my mouse is to this point. So the whole, I guess the whole width of the valley is 1.4 millimeters across there. And there are two first balls. Anyway, well, I'm glad I didn't bore you to death, Zignal. You know, when I'm not presenting, I'm doing a lot of work, and sometimes it's quite tedious. I have a high degree of patience for tedious work, which is just as well. Oh dear. But it's, you know, I like mushroom picking, like, and it's kind of like mushroom picking. There's treasures hidden within this landscape, and you have to walk around it to find where they are, and then ask yourself, why did that grow there, or why did it go there? Did it grow or did it go? So I've got some other images actually from the valley, which I will go to, because why not? Now, these are actually out on the what I call the floodplain. So these are kind of, I've shared these, and in fact the optical images from the Narugo $70 lens are actually better in many respects. And so this shows where the plasma, what they were called plasmoids in the past, I guess, have traveled across from the main channel out across the just the raw brass. So we can have a look at this, and maybe we'll find, it'd be very exciting to find one of these balls at the end of this channel, one of these channels. You see how that gets messed up? Look at it. It's just all twisting and sloshing around. Look how curved this is. It's curve, curve, curve. And they used to think this was a discharge traveling across the surface, and it's not, because this is between two plates. This is something, look how, I've got to do some better resolution work on these, but look at the way that is. Look at the curling, curving, and we know now that this goes up here and it twists around and comes under. It goes around, twists around and comes under, or it's going around the other way. Can understand what you're looking at more. Great, yeah, I've actually got some mushroom plugs and Beck for two different types of cellulose eating mushrooms, and I've actually got some wood in my cellar, and I've yet to plug them at the right time of year. The spores are probably dead now, so I might have to buy some more. Look at what this has done here. Look at it. Oh, hello. What's this? What's that? I don't know. So many balls, I could get confused. This is interesting here. So what I intend to do is when I, hopefully, if I had enough time on an SEM to categorize, you know, maybe catalog maybe 5, 6, 7, 8, 9, 10 of these, what I consider are the core from ball lightning and micro ball lightning in this case. It would be nice to see if I could get a strong neodymium magnet and run it over the sample, and maybe these things would jump onto the magnet, and then I could look at them individually. And actually at SciTech they have an ion beam, and you can use this ion beam, and I would like to take one of these balls. Now this is interesting, look at this, it's got like a splat mark with a ball in the center. This would be interesting to see what this is. Be interesting to see what that is. And if hold on, what have we got there? No. It'd be interesting to use the iron beam to see if we can cut one of these balls open to find out if it's hollow. Because that would be pretty awesome, wouldn't it not be? If, oh, hello, what's that? That looks interesting. Look at this splat. It's like in the middle of nowhere over here. It's in the middle of nowhere. And it's just gone. Okay, we got another image here. Hold on before I go. What's that? What is that? Okay, now I like what I'm seeing here. Look at this. Look at this. Oh my God. You have this splat in the middle of nowhere. It's gone churny, 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 and then there's some sort of boundary here. Then there's this black area and a ball. I like this whole structure a lot. I like it a lot. And also that ball looks like it's got a ring circumference and it's on one end. I like this. I want to look at this particular area. I hope I can find it again. I mean, when you're under the SEM, something that's 8.5 by 7 or 6 centimeters, it's basically like looking at a continent. I like this. I like this a lot. I really like it. You've got like a trail of all kinds of churniness going on. Again, with our sort of twisted structure around it. I think if we can get this at the kind of resolutions that I've been sharing some other things with you, and if this is one of these iron-rich balls, and in fact, this whole area, look at it. There's one there. Is that one? I mean, it could be that the end of these trails could be very rich. No, I like that a lot. I like that a lot. For many reasons. I really like this ring here because this looks like a DeVow impact. It's a French guy that had some Evo strike marks, or that actually I think he referred to them as monopole. And I think we've got that here, and I don't know exactly what we're seeing there. Is it just more of this? I don't know, but this whole thing is, I really like the look of that, very much so. Look at this splat here. Look at this splat. Here, look. This looks similar, but it's different. I mean, we got like a hexagonal crystal in the middle of this structure, and it's kind of off to the side of this one. It may actually be that what I call the Badlands or the floodplain, they might be much more interesting than the main channels. Might be more rich pickings. Hey Bob, can you explain how these brass pieces were arranged in the reactor? Actually, I've done that, but yes, essentially, I've got some media that I worked on, and I've not finalized it, but basically you had the anode, then there was a gap, and then you had two brass sheets and a brass sheet below. and then that was on a support structure. And the discharge ran for about, it's like mostly a corona discharge, and for about 100 hours. Now I like the end of this channel here because we've got some structure at the end of it with a radius, and the radius here is about the width of this channel. So I'm really liking what I'm seeing here. Oh, look at this. Here's another one of these structures. You've got, or maybe it's the same one, but you've got something here, which is like a pentagon type shape, and then something in the center. So yeah, I'm really liking this area. So it doesn't have all the beautiful. Oh, look at that! Look at that! I think we're going to be onto a winner. Look at this. This might be good. I think what I need to do is re-look at these and then see if they are within this 27 micron quanta, or the quanta of the first one. Now, actually, when I did the look at this the first time, there's a couple of things I picked. Look at that. Look at this. Now that looks like it could be an iron-rich ball in there, and this looks just like what I saw in the Imperial War Museum. It's like the same kind of oval structure, built-up area with your thing in the center. Right. Yeah. Okay. Without being too boring. So I looked at this area here and this one. So I'll show you what that looks like. So this ball here looks like that. And this looks very similar to the kind of balls that are shown by Matsumoto. And I will, because I've got it here, I will show you what I mean for those people that don't know. So he was using, he was basically using discharges in potassium hydroxide. So he had any number of these kind of balls. And in fact, it's interesting because he has this ball which has a growth out of one side and a hole, and that is at the same angle as oxygen molecules supposed to be structured. So you've got like the thing growing out of here, and you've got a hole over this side, and this is like whatever it is, the angle of an oxygen and hydrogen. Something similar to that. So he's got many balls like that, where it has a hole on the top like this one. And Solin says the nuclear reactions occur within that. He's got these ones where you get paired balls like this, like those dual. I'm going to do this. I'm going to do this because then you can actually see with some fidelity. These ones where you got paired balls, like those meteorites. You get those asteroids where you get two paired together. You get quite common to see that. Yeah, Solian said the reactions, nuclear reactions, occur within the hollow ball, and then the material comes out, and you can see it happening here and here and down here and here. Yeah, so here you go. There's your ball with your thing and a hole on one side and stuff, and then here's the one that's very similar to what I'm showing you, or I was showing you. I'm not showing you at the moment. Oh, there we go. So have a look at that. Of course, bear in mind this is from lead. And then look at what I'm showing you here. Ta-da. So there we go. There we go. That's Matsumoto's one. And so Solin says that the reactions occur inside these hollow balls, the nuclear collapse reactions. And so I looked into some of this area here, and you can see this kind of semi-hexagonal structure with, it's got these little petals on it. And Matsumoto describes, I think in his 1990 or 1992 patent paper, the petals that you see. And so I don't have the SEM data here for this, but I do have it somewhere. Again, this is probably carbon or silicon that's being synthesized in these structures. Again, you've got it here. And this structure is what? This is 27 microns across, so could be of the same kind of family of structure. Anyway, there we go. Right, I will ask. I will ask you if you've got any questions. So here's some other balls that this is found on a different sample, and here is a ball where you've got a hole here and another structure here at this angle. So we'll talk about this at another time, but I think that's probably enough for tonight. Anyway, so let's go back to the presentation and we'll have a quick summary. So I was answering a question by David Butlier. Could you use the optical imagery and find these balls? Well, I looked at the optical imagery and it just happened to be the very first one that I decided was successful enough. And here it is on the SEM upside down, and this is the image where I first spotted the ball, and we zoomed into the ball, and this is the optical imagery, so you can see how they kind of match up, but there's some parallax and some angle shifting, which doesn't make it perfect, but still I was able to generate this image, which is the two paired together in the shot. With some sort of effect on the coloring there. Then you know, everyone's got YouTube, so they can everyone's got access to Google, so they can obviously look up micrometeorites, because I suggested these things can look like what are claimed to be micrometeorites, and I don't believe that the majority of them are. I believe that Ken Shoulders is right in saying that the ball lightning is what is at the head of the forming discharge channel for lightning, and that all lightning is created, the discharge channel is created by a ball lightning first, and you can see this on slow motion video that he shared many years ago, and the same is observable on very high speed videography that you can see even on YouTube. You can go and have a look at that and have a bit of fun, and you can see it tracing down, and then when it's got down, you can see the discharge. And so I think that's exactly what's going on, and so I think that those things that people find in gutters from their roof and on streets and stuff, I believe that they are not necessarily micrometeorites. I believe that they are from the core and ball lightning, and the placement of structures in Vega, which I've walked through today in a little bit more detail, for me, absolutely categorically remove the possibility that this is a meteorite that landed in Henk's device. And I believe that the placement of structures inside Ultra, which I'll discuss on Sunday, I believe that is also supporting this hypothesis that they are formed by the actual experiment. And then there is the elemental makeup, and this is from the day on Monday when I took this, and it's almost exactly FeO2. And I talked about how that is recently discovered in 2016 oxide of iron that is believed to occur in the lower mantle, and it requires 76 gigapascals of pressure. Gigapascals, 750,000 atmospheres to form, and 1,800 degrees Kelvin, and the reactor, the Vega reactor of Henk, was only at very low pressure, residual air pressure. And then I showed that this was confirming the elemental makeup, and I showed that the sample spectrum 39 actually included the edge of this piece of detritus on the outside. And this might actually be some material that for some reason it was cohering or not. I think it's just a detritus. When this came back into our 3 space, it kind of like grabbed this bit and got stuck to it. And so I think that accounts for the small amount of copper and zinc that's there. I think it's essentially all iron, manganese and oxygen. And then we talked about the fact that this tongue-shaped section is carbon on the inside, and it's one of the growing supporting evidence that on the coherent matter, when the coherent matter inside sheath comes out of coherence, it deposits the first element that it can deposit most of is carbon. And then we looked at the pomegranate and how that was formed, where it was formed, and the fact that it seems to be producing sodium and oxygen. I did some rough calculations how the sodium and oxygen could come from the decay of copper, including carbon, and then the sodium gets left behind, and the oxygen carbon isotopes that are synthesized could then go to form the iron that's in the ball lightning. And so one is actually feeding the other. And so that's that. And then I talked about the Sumerian or Assyrian gods here, and the fact that they used pomegranates as a symbol. And I had the slide from Ode from January 2018, and it's kind of if it wasn't for what I call the event, which I discussed in my movie, and it wasn't for the realization that there was a purpose. So, you know, if I had rediscovered this technology and realized that it could produce unlimited energy, I would strike a deal with a person or a country that has a lot of energy to work a deal. Say, look, you know, we could just use this technology now, and you know, basically everything you've got on the ground is worthless. Or you could help us come up with a reason to destroy all the evidence that this is an ancient technology that humans have used on the earth before. You could help us with a narrative, and we'll let you sell your energy resources for the next 20, 30, 40 years, 50 years, 60 years, until they kind of run out. And we'll already have this technology ready to go. And it's like, isn't it amazing? We discovered this new technology. Ha ha ha. And all the evidence will be wiped clean from all of the places that it is present. So, you know, I think we know what happened. I think we know how it happened. And I think probably what I'm suggesting right now is the motivation. It's just a tragedy. It's just an absolute tragedy. But if it wasn't for the event and my realization that it was the same thing, and the weird desire to go in and do specific things in the countries where all of these artifacts are, I'm not sure I could have got anywhere close to solving what coherent nuclear transmutation and ball lightning was. So, as I've said before, sometimes you meet your fate on the path you chose to try and avoid it, if you know what I mean. I think someone showed their hand in order to protect their technology, which wasn't their technology, but they wanted to pretend it was. And so they actually revealed the technology. And so I think we can just look to the positives. I think people would say that God has moves in mysterious ways, and we can't bring back all of the people that have lost their lives or had their lives denuded or never were born or whatever. But we can work to ensure that this technology is used for the positive that it can do. We can have regeneration and resurrection for this technology, and to stop this nonsense about all of the never-ending everythings, the never-ending disease, the never-ending bogeyman, the never-ending climate change, the never-ending whatever it is. They've always got a never-ending something that they want to put fear into your hearts. You don't need fear. You just don't need it anymore. See nature, what it is, and it's all its absolute amazing glory. And as I said in 2017, this is Revelations, you're in it. I think the game's pretty much up. So, with that, I'll take some questions. Yeah, even the end of disease, Dan. Okay, I'm going to scroll back and see if you've got any questions. I'll leave this slide up because I think it says a lot. You've got nature as people understand it on the left. I think you've got nature in a new form, but it's not a new form, it's eternal, and it's what underpins everything. And you've got old humans from probably tens of thousands, if not hundreds of thousands of years ago, living on this planet that knew exactly how it worked. Exactly. Absolutely. Without a shadow of a doubt, they knew how this technology worked. And it's just a scam. Everything's just a scam. So fluffy elements matter. Yes, they do. Really. Da, 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 da. Okay. Yeah, David. I think David, about the FeO2. When you said, I think you said, oh, it's magnetite, and I go, no, it's not that. That isn't magnetite. And I'm thinking, but I don't even know what it is. And that was on the stream on Monday night, having only seen it on the Monday afternoon, and so for me, the fact that it's FeO2 puts it in a whole different class of unexplainables, which is explainable, because it supports the concept that this has to be produced under a self-organized structure, but that one that has an immense compressive force, or cohering force, as you might like to say. If you're compressing something, you've got less degrees of freedom. So I look at it like this. If you've got a room and it can take 5 people, no, you've got a room and it can take 100 people, right? And you've got 10 people in there. They've got lots of space to move around, right? But if you put 50 in there, they've got much less space to move around. And they can only run with a certain speed before they bump into someone. But if you put 100 people in there, they can't move at all. They're stuck in their little space. So kind of that's how you can visualize it. This kind of implied that it was under extreme pressure, and now we have a material that the nature, the journal Nature, is saying has to be produced under these pressures. And by the way, our quantum mechanical calculations calculate that it should be significantly magnetic. And so you have some things which are just completely lining up. And they specifically say that if you dope it, and I think they give some other elements that they suggest doping it with, that it will then be even more magnetic. Now, I wonder if it's the manganese in there makes it much more magnetic than the dopants they're suggesting. In fact, that putting that aside, we have an opportunity within just what is it, 600 microns or 700 microns of that one. We have another one, and if that is FeO2 perfect ratio as well, then it's not a one-off. It's not a one-off. And then maybe we have another one down, and maybe we, like if I can find like 10 examples on this sample in different places that have got the same ratio, then it's like there we go, it's done. Yes, Corky, I sleep after sharing, so it's off my mind. Yeah, I don't want to have to think that I something might happen to me, or that I might forget something. Because then what was the point of spending the time that I did to find out something? It's like pointless, isn't it? So you might as well get it out the door. And then you guys are fantastic. You give back, and sometimes that's not directly leading into a direction. Sometimes it is, but sometimes it shows. The truth is always the truth. Nature is showing you here and here, and this guy is recognizing nature. You know, the truth cannot be changed. It just is what it is. And I believe the tree of life is exactly represented by these cones and pomegranates. I think they knew exactly how this worked. Corky, this is so immense. It's so immense. Um, I would love there to be people, and it's exotic vacuum objects. What Shoulders did by publishing his book, self-publishing his book, and sending it out to people, and then, submitting his patents, I think was one of the greatest gifts to mankind. But I think he recognized that this is nature and that it wasn't his to keep, and that it was far, far bigger than he could ever imagine. And great that he was a kind of character that just liked discovering things and not actually implementing them into some commercial venture. He just liked the discovery process. And I guess he just discovered this isn't a discovery because it's already there. I think in 2006 at MIT, he said they needed to do this. Beeswax and copper and cat hair. They had everything they needed to produce exotic vacuum objects. And I believe the G culture and the Syrians and probably whoever it was that they learned their stuff from prior to the Ice Age, and probably for hundreds and hundreds of thousands of years after we arrived. I think it was used all over the planet, such that it was celebrated in all the architecture, and it was celebrated in mass-produced lanterns and all kinds of artifacts. They could see in their science what they saw in the nature itself, what nature did, and all it is a reflection of what happens in how matter arranges itself. Is this overall driving force, which you would call God, like real God. It's intent, it's conscious intent. And it's such an amazing design. If I was to say anything is divine, it's the beautiful way it just all works, and just simple logic. It explains how you take matter apart, how you put matter together again. It follows simple rules, but it is so powerful in what it can create. And it comes down to the Baroness, John Hutchison. Ken Shoulders would never have got into trying to work out what he worked out if it hadn't been for John Hutchison. And John Hutchison would have never done what he did if it wasn't for Tesla. And Tesla arguably would never have done what he did if he didn't see a snowball rolling down a mountain. Yeah, the Prairie device is very similar, I believe, to the device that I saw in the facility by Piantelli, where he's curing people of various ailments and has been for decades. It's all frequencies and energy. If I was to listen to myself now, a few years ago, I thought, oh my God, who's this crazy new age person? Like talking about crystals and healing and the energy man, like chi. It's like it's exactly how it works. I do have the bonus that I've whatever life path has sent my way, it's given me the opportunity to delve into it to the level where I probably seem a little less crazy than most people, but okay. So I'm going to give you another 12 minutes for any questions if you still got them. I think what happened earlier with the stream was that the facility that I'm in has a shared internet, and there were lots of people in the building up till about 11:30 here this time, or 11, and so I believe that the broadcasting was just not able to cope. So this should not occur on Sunday. Anyway, the camera's not switching off every 10 minutes, and my computer held up today, so we're making progress. Now, I will say, I'm only human and I'll probably get things wrong. In the past, I would go through my streams, and YouTube had a feature where you could overlay a piece of text, and if I'd made a percentage error, or I'd made an error where I'd called something which obviously I was meaning something else, and often I would correct or use the correct term a little bit later down in my conversation. I would go and correct that, but then YouTube removed that, and it's harder to do now. Yeah, I think you can put cards up or stuff, but and misuse them in that way. So it's just a little bit annoying. But I think the important thing for me right now is to get as much out the door as possible, as fast as possible, to help the experimentalists and to help other people understand that this is a real thing. It has profound implications for our future, and more than anything, there are decisions being made now which you can't be undone. And by that I mean, once you've written the contracts to say 100 billion's going here, 100 billion's going here, we're going to be mining this building, we're going to be mining this mountain, we're going to be drilling this oil, we're going to be flooding this rainforest, you know, we're going to be going on these military misadventures, we're going to be investing in this type of transportation. All of these things are unbelievable waste of human life in the light of what the potential for this technology. Unbelievable. Also, you know, once you've got unlimited energy, essentially, you can desalinate water, you can do all kinds of things, and you also don't have to chop down rainforest wood or wood generally and denude landscapes in many ways to get, you know, energy. You know, the number of countries that I've been fortunate enough to go to where I've seen local people allow their family to come into a protected forest and take wood out of it, and therefore denuding it, and they're just trying to feed their families, and you know, the carrying capacity of the Earth is absolutely amazing with this technology. But moreover, we can learn to respect it and see it for its incredible beauty and phenomenal nature. And also look into the heavens and where we can go. Can we build amazing propulsion and travel to the stars, Bob? In 1957, I've talked about this before, and I'll talk about almost precisely how I think it works, but it's a very much larger story. It's another section of O'Day, and I need to work into that. But you already have so much that you need to know for how this will work. But basically, yes, Winston Bostick, I think in 1957, gave a presentation where he was referring to his work coming out of plasmoids, and he said, using this technology, I think we can get to Mars in 4 hours. And I've talked and published the CIA debrief of some Russian people working on the energetics program from 1992. And they said, using this technology, which, by the way, is the same technology as cold fusion. Bearing in mind, cold fusion was announced in 1989, and this was 1992. So the Russians were well ahead in terms of understanding. They said it's the same technology as cold fusion. We can get to Alpha Centauri and back in 12 years. And the energy required would come from 1 kilogram of iron. And by the way, that the means of getting the energy would be also the form of propulsion. And all of those things are completely consistent with exotic vacuum object technology. And I will walk through precisely why, in my view. And so I believe that we can get to Alpha Centauri in 6 years with between 0.5 kilo and 1 kilo of iron. You know, it's about 4.8 light years away or something, and so you would need to go at about 0.8 of the speed of light, and that's a very, very important number given what we know about exotic vacuum objects. Elias, the guy called Stoyan Sargachev, I have his books next door somewhere. do. I think they're buried. Maybe they're on the shelf. Let me have a look. They might be on the shelf over here. Yeah. So Stoensag was one of the few people that actually replicated John Hutchison, quite by accident. And he came and spent a few days with me in December in 2014. And this is his magnus opus. He developed a field propulsion device. In fact, he has another book. I've got it somewhere, not here. Maybe it's in my house. On field propulsion. And he said that if I manage to solve cold fusion, he will give me anti-gravity. I'll give you anti-gravity. That's what he said. If you manage to solve cold fusion, I'll give you anti-gravity. And I think that was kind of a bit of a joke actually now, because they're the same thing. And his propulsion device, it used what do you call it? High frequency and corona discharge, and it was on a cradle, and so it moved. So yeah, so I think they're related. I would like to do that, but at the moment I'm focusing on dealing with radioactive waste and understanding the cold fusion how it works. And I think what I want to do is kind of like finalize the concepts for direct electricity production without the destruction of physical containment. And I think that's going to be, I'm working towards that, and you'll see. But I kind of really needed to fully understand why it does like to destroy matter and transmute matter, and I think we're getting pretty close to that now. Well, infidel apostate, as soon as the power that be get wind of this, will suffer unfortunate accidents. That's another reason why I like to share immediately. The point is that I've encouraged people to download the channel. When I say download the channel, it's for a backup, not necessarily for rebroadcasting. Although I have said I'm happy for my movie to be rebroadcast, because I think that if it wasn't for the event, then my movie would never have been possible, and all of the other things that have come from it, I'd probably still be fumbling around with the old concepts for how this technology works. Okay, if people have specific questions, please go to the blog post on remoteview.icu and ask them there. If you haven't subscribed to that, then that's probably the best way that you will get early notification, because it goes into your email box, whereas on Facebook, YouTube, and Twitter, they only send to a proportion of the people that are subscribed or liked or whatever it is. Whereas if you're subscribed to remoteview.icu, you will literally get every one sent to your email box. And I will be backfilling some of the presentations in the future, and I will do a separate blog post to say which ones I've backfilled. And thanks for the people that have subscribed there, because that really has made a huge difference in the last 10 months to my ability to focus on the work. And yeah, sorry for the hitches here. I tried to spend a bit of time, and hopefully I'll do more for Sunday to make this work even more smoothly. But for me, it was actually just within about 20 minutes of Monday's presentation. I found I solved the iron FeO2 conundrum I had, and realized that it could only be explained by intense pressure, which we know didn't exist in the reactor, and therefore it must be something that's causing that intense pressure, and that's exactly what I expected. And so yeah, it's been a pleasure to go through this, and for me also when I saw this structure, it was like, well, I know what that is. And then the cones and so forth. We do not own this. We do not own it, but we should be using what it can do positive for humankind and for the planet generally. And the rest of the stuff that's going on in politics and in real politics and geopolitics is just nonsense of the highest order. And on that note, I day before yesterday, I did my IgG, and having had the sniffles between March and April 2020, I can inform you that my antibodies are still at 53% over the amount required by the WHO. So, long-term protection from being exposed. And I had food poisoning 3 times in my life. I don't want to say too much about it because they'll probably strike the video for that. I had 3 times food poisoning in my life, and that was worse. And I think I've had the normal seasonal flu, which has been worse a number of times. So I think keep yourself healthy. Have some pomegranates. They're great. I've got one at home that I'm going to enjoy for breakfast. And it's a great, great fruit. And it is the fruit of the gods. And I think with that I'll say good night. Arrivederci. Buenas noches. Dobry dzień. And let's work together. Let's be coherent. See ya.